Hey, what's up, kids? How you doing? Hope you're having a great day. This is section 11.2. We're going to find surface area today of prisms and cylinders. Even though a cylinder is not a polyhedra, we can still find the surface area of it. And prisms and cylinders have a lot of similarities to one another, and so that's why they're grouped together. So, first off, from last week, you remember that a prism has two bases, both the same shape, both congruent, both going to be parallel to each other, and then all the other faces are rectangles. And all the other faces, by the way, are called lateral faces. So you have base, base, and then lateral face, lateral face, lateral face, lateral face, lateral face, lateral face. Six lateral faces around here as well. They're all rectangles, okay? Why I'm telling you that is that that's going to help us out a lot with understanding surface area, okay? Well, first of all, surface area. Surface area is just the combined area of all the two-dimensional shapes that make up this three-dimensional object. So it's basically anywhere that an ant could crawl, we are going to calculate the area of that. Or if you had to wrap this in wrapping paper, what would be the square units of wrapping paper that you would need to cover all the faces? Okay, and so if you understand surface area a little differently, then what you could look at is you could take a three-dimensional object and just flatten it into two-dimensional shapes and just lay it out flat on like a sheet of paper or something. And this, by the way, is called a net. A net is a two-dimensional representation of all the faces of a three-dimensional figure. Okay, so this net, if you were to put this together, some of you might have done this in like elementary school. You made like a net of a cube, and then you cut it out, and you taped all the shapes, and you taped all the squares together, and it made a nice cube. And so this would be a net of a pentagonal prism. Okay, and the reason I have this laid out is that it's easy to see what makes up the surface area. Okay, you have a base and another base, so we have two pentagons that are going to be part of this surface area. And then what you have here is you have a bunch of rectangles, but guess what? A bunch of these rectangles are all put together to make up one big rectangle, all right? And the area of a rectangle, let's just remember the area of any rectangle is length times width, or base times height, or whatever you want to, look at it as. Okay, well, here's the deal. This length, or base, or whatever you want to call it, this length right here, okay, has a relationship to this pentagon. Watch, okay? Look at the yellow side of the pentagon maps right onto the yellow part of that length. Okay, now watch. This red face would map right, or not red face, but red edge would map right onto this. Okay, this green one would go right to here. Okay, let's go blue, maybe blue. Yep. This blue one here would map right onto this right there. And lastly, this black one would go right to here. In other words, the length of this right here is actually equal to the perimeter of that base, which is a great relationship to understand. So this big purple rectangle, one of the units of measurement here that make up this rectangle, the length of it or the base of it is going to be the perimeter of our pentagon. Okay, the perimeter of the base of our prism. And the other unit here, which is this guy right here, which is the height of the rectangle, if you will. That is going to be the distance between the two pentagons when we put them together. Okay, so we have a big rectangle in here, this big purple rectangle that actually is going to be the perimeter of our base times the height. That's how we're going to find that area. Okay, and so basically, to find the surface area of an entire pentagonal prism, you would take the area of both pentagons and then add them to that rectangle in the middle, which would be the perimeter of one pentagon, times the height, or the distance between the two pentagons. And thus what we have here is we have the surface area formula for any prism. Okay, so let's write this down. The surface area of any prism, you're going to want to write this down in your notes so you have it for reference, is the following. Okay, surface area is equal to 2 times the area of each base, because we have 2 bases. And again, in a prism, our bases can be pentagons, our bases can be triangles, our bases can be rectangles, our bases can be squares, our bases can be any polygon, really. Okay, plus the perimeter of a base, perimeter, come on, jeez, times the height of our prism. Okay, so let's write this down. This capital B, that's area of a base. Area of a base. And we have 2 of them. That's why it's 2 times capital B. This capital P, perimeter of a base. Just like, oh my gosh, that's a base. Just like on the last page when it was a pentagon. One pentagon's perimeter was one of the lengths of that big rectangle in the middle. And then a height, okay, distance from base to base. Distance between bases. So we can use this formula, right, to find the surface area of any prism. 2b plus ph. Okay, now if I just ask for lateral area, sometimes like when we're doing things in the real world, we only want lateral area. Lateral area is just surface area minus the 2 bases. Okay, so a surface area minus 2b. And what that means is that if we go back to, oh, like let's say this thing right here, it would only want the rectangles, right? The blue, and it would be, you know, these rectangles going around. So only the area of those rectangles, not the hexagons. And if you're ever like painting a house or painting a room, you would obviously only want to paint the walls. You wouldn't want to paint the roof or the floor, and thus why lateral area might be, you know, something you'd want to calculate. So if your worksheet or anything ever wants you to calculate lateral area, do not include the bases. It's the surface area minus the bases. Okay, so anyway, now let's get into calculating some surface area here. Let's do this for a rectangular prism. Okay, so if I ask for the surface area of this, first of all, a rectangular prism is unique. You actually have options for what you want to call your bases. See, this thing's already sitting on the bottom face there, so my eyes see this as a base, and thus this would be the other base. But like I said, in a rectangular prism, you have some freedom. You actually could say, actually, I'm gonna call this my one base, and this one that's congruent and parallel to it, opposite it, is my other base. Okay, and you actually would have the front and the back that you could call bases as well. But I'm going to go back to, let's make sure we're all on the same page, and let's call this bottom face a base, and this top face a base. Okay, so the surface area of this thing is going to be, like we talked about, 2b plus ph. Okay, so first of all, b, which is the area of one base, is just 8 times 3. Area of a rectangle is 8 times 3, which is 24. That's what's going to go in there. Okay, perimeter of a base, that's just of one base now. Perimeter of one base, and if we were to stretch this out and make a net of it, it would be the length of this big rectangle in the middle. But we already know it's going to be the perimeter of one of the bases that we're looking at, which is 8, 3, another 8, and another 3 makes 22. The perimeter of one base is 22. And the height, which is the distance between your bases. See, people will look at this and say, that's the height, 3, that's the height, 8. No, it's not. Once you declare your bases, your height is the distance between the 2 bases. So in this case, it would be 2. Okay, 22 goes there, 2 goes there. Whoops, I better go get my calculator so I can do all this with you guys. Hang on. Okay, I'm back. So 2 times 24 plus 22 times 2 gives us 92, right? The surface area of this rectangular prism is 92, and it's feet squared. 92 feet squared. And interestingly enough, if you go back and you declare other faces as your bases, whoops, I don't necessarily want to erase that, but I do want to erase. Like if you go back, and you could pause the video and do it yourself, but if you go back and make this your base, thus this would be your other one, you could find the area of that and double it, right? 2b. The perimeter of this, which would be 10, and then the height would be 8. And you're going to notice, right? Actually, let's just do it real quick. 2 times 6 plus the perimeter of that would be 10, and the height would be 8. And notice what happens. It's 80 and 12, which also makes 92, regardless of which way you look at this. Okay, so for a rectangular prism, you have options for what you want to call the bases. Now, when it's not a rectangular prism, such as, oh, I don't know, this guy, this surface area of this triangular prism, now there's only one option. Okay, this is a base, and this is a base. Even though it's not sitting on its base, it's more sitting horizontally like a Toblerone bar or something like that. But anyway, these two congruent faces are obviously, they're parallel to each other. They're obviously our bases here. This is a triangular prism. Okay, so finding the surface area of this, and by the way, it says right. The reason it says right is because if you were to draw a line from the middle of this triangle to the middle of this triangle, it'd just be straight up and down. It would create a 90-degree angle with, you know, it basically straight vertical if it were sitting on this versus slanted. Some prisms have a little slant to it, like the Leaning Tower of Pisa or something like that. But anyways, so that's where they get the word right from. But anyway, the surface area of this right triangular prism, okay, which is 2b plus pH. Okay, so 2 times the area of one base. Okay, I taught you last chapter that the area of an equilateral triangle, there's a shortcut here. 1/4 times the square root of 3 times side squared. Okay, taught you that in a video a couple weeks ago. Or you could draw a height, and then the base would be 6. You could find the height using Pythagorean theorem, with this being 3 and this being 6 if you wanted to. But there's this nice little shortcut here that helps us find the area of the base. So 1/4 times the area of that triangle times the square root of 3 times 6 squared goes in there, right? And there's 2 of them. That's why there's that 2 there. Plus perimeter of a base, which is 18, 6, 6, and 6. And then the height. The height, remember, is distance between bases. It's not the height of this triangle, but rather the height of the whole prism, which is distance between bases, which would be 10 here. Okay, so this is calculation now. I'm going to take this 2 and this 1/4 and call it 1/2. So 1/2 times the square root of 3 times 36. Half and 36 make 18. So now I have 18 root 3 plus 180. That's a plus sign. And let's just plug that into our calculator now. 18 times the square root of 3 plus 180. And your final answer here for surface area of this prism is 211.18. And let's see, what were we in terms of units? Inches. So this is inches squared. Okay, that's surface area of a prism. Now, let's talk about a cylinder for a minute. Okay, if we come back to this, this is a surface area of a cylinder, and it is broken into a net again, like flattened out. So you have 2 circles. Okay, and then you also, again, have a rectangle. It's like a soup label. If you took a soup label off and put it on your countertop, it would definitely be a rectangle. Okay, so what we have for a cylinder is we have the same thing. Okay, the surface area of this is still going to be 2b, right? 2 base. We're actually going to make that a little more specific because we know it's always going to be a circle in a cylinder. Plus, okay, now watch. This right here, for one of the units in the rectangle, the length of this rectangle, would wrap all the way around this circle. So yes, it's the perimeter of the circle, but we don't call it perimeter for a circle, we call it circumference. Okay, and then this length right here, right, we're finding this part here, like this part here is finding the area of this rectangle in here. And so it's circumference here, and then this guy right here is just height, different distance between the two circles. Okay, so it looks really, really similar, except we're going to just call it 2b plus ch. And actually, we can specify that even more. It's 2 times pi r squared, right, area of each circle, plus the circumference formula for some circumference is always 2 pi r, and then h times h for that last unit there, okay, or for that last length there. So actually what this ends up being, and you'll want to write this down, the surface area of any cylinder is 2 pi r squared plus 2 pi r h. Okay, r is the radius of the circle, and h is the distance between your bases, or the distance between your circles in your cylinder. Okay, so if I just go and let's do an example here. If we want the surface area of this cylinder, we would do the following. All right, we'd write down the formula: 2 pi r squared, there's two circles, plus 2 pi r, this is the circumference of one circle. See, people look at that too and say, is this for two circles? No, the circumference of one circle is 2 pi r, and then height is distance between your circles. Remember, this right here is the rectangle, the soup label. This right here is both circles. So 2 times pi times 4 squared plus 2 times pi times 8. Oh, I'm sorry. Back that up. 2 times pi times 4 times 8. Okay, now 16, this is 16. 16 times 2, that's 32 pi. Jeez. My stylus, which I spent $30 on, is not working out very well right now. 32 pi. This one right here is 4, 8, and 2 is 64. 64 pi. So 32 pi plus 64 pi. 96. Oh my gosh. Back that up. 96 pi meters squared for your surface area here. Okay, 2 pi r squared plus 2 pi r h. Okay, and lastly, before I let you go, let's do a problem where we're given the surface area, 592.19, and we're asked to find the height of the cylinder. Okay, so we plug in what we know and find what we don't. So remember, 2 pi r squared, 2 times pi, and the radius is 6.5, plus 2 times pi times 6.5 again. I'm going to move this. Move this for us. Shrink it down a little bit, because it's 2 times pi times 6.5 times your height, which is what we're trying to find here, right? Find the height. Okay, well, this is just a calculation. 13 pi is what this is. Okay. Oh, I messed up. That's 2 pi r squared plus 2 pi r h. So back that up. That's not 13 pi. Okay, that's actually going to be something ugly, but 2 times pi times 6.5 times 6.5, which is 265.46, plus there's 13 pi. Okay, that's equal to 592. All I'm doing right now is just solving for h. So I'm going to subtract the 265.46 from each side. 592.19 minus 265.46 is equal to 326.73. Okay, it's equal to 13 times pi. Come on. 326.73 equals 13 times pi times h. Okay, and then lastly, I'm going to divide by 13 pi. And make sure when you're dividing by that, the 13 pi is in the denominator, so put parentheses around all of 13 pi when you're dividing that in your calculator. And what you're getting is a height that's very, very close to 8. 8.0001, blah, blah, blah. Okay, so your height is 8, and what is the unit that we were in? Centimeters is the height of our prism, or our cylinder, rather. Distance between your circles. Okay, so I went a little bit long today, but surface area of prisms and cylinders. Enjoy it. You'll have homework coming tomorrow.